At 4:44 in the morning, the first transport load arrives at the Seaboard Foods processing facility in Guymon, Oklahoma. The truck carries 185 hogs. Each animal weighs between 260 and 285 pounds. The RFID reader at the plant's receiving gate scans the transport documentation as the truck passes, the load manifest, the farm of origin, the departure time, the health certification, and logs the arrival against the kill floor schedule that was set 3 days earlier. The dispatcher who assigned this load to this truck from this specific contract finishing farm in Texas County did so, knowing the Guymon plant's daily capacity requirement, 18,000 head. Meeting that number requires precise coordination across 400-plus contract finishing farms spread through Oklahoma, Kansas, and Texas. This truck is one of more than 90 that will arrive before the end of first shift. Seaboard Foods operates a fully integrated pork production system built around the Guymon plant, a facility that processes approximately 3 million hogs annually, making it one of the largest single-site pork processing operations in the United States. The system that feeds it extends backward from the plant gate, through the contract farm network, through the 5 feed mills that supply those farms, through the company-owned sow farms that produce the pigs, and all the way to the genetic selection program that determines what those pigs look like before they are born. Every pig in the system carries an RFID identification number from the moment it enters the tracking system as a weaned piglet. That number follows it through nursery, through the contract finishing farm, through transport, and to the moment it enters the Guymon facility. The data accumulated against that ID, weight history, health treatments, feed conversion estimates, farm of origin, moves with the animal through the pipeline, 3 million hogs per year, one pipeline, from genetics to the processing floor. Seaboard Foods chose Guymon for its processing hub for reasons that western Oklahoma's geography made obvious. Texas County, where Guymon sits, occupies the Oklahoma Panhandle, a flat, semi-arid strip of land where the prevailing winds blow consistently from the southwest, the population density is low, and corn and grain sorghum grow on irrigated high plains soils. These conditions favor large-scale livestock production. Dispersed population reduces neighbor conflicts over odor and agricultural traffic. Irrigated grain production provides feed ingredients in proximity, and the flat topography suits the large footprint that both hog finishing facilities and a major processing plant require. The Guymon plant opened in 1995. Seaboard, a diversified corporation with operations in ocean shipping, odd power generation, and food production, had identified the integration opportunity in pork production at a moment when the industry was consolidating rapidly. The model it built owned genetics and sow operations, contract finishing farms, company feed mills, and a single large processing plant. Mirrored the structure that Smithfield and Murphy Brown had developed in North Carolina, but adapted it to the geography and demographics of the southern plains. The contract farm network that spread across the Oklahoma and Kansas panhandles and into the Texas panhandle over the following decade brought hog finishing to a region that had not historically been a major swine production area. The grain production base was there. The land was available. The contract growers who signed on built finishing barns to Seaboard specifications and raised pigs they never owned on feed they never purchased, receiving a service payment per pig marketed that the contract defined. The Guymon plant's processing capacity determined the size of the contract farm network. 18,000 head per day across 260 operating days per year. The approximate number of days a plant of this type operates across 2 shifts requires approximately 4.7 million hog equivalents of capacity in the contract farm network to maintain a consistent supply. At an average barn inventory of 2,400 head per farm, the 400-plus farms supply that pipeline, assuming a 180 to 190-day cycle from placement to market weight. Seaboard's genetic program begins in company-owned multiplication and multiplier farms, where the pure genetic lines that produce the commercial pig are maintained and propagated. The commercial pig that finishes at 270 to 285 pounds in approximately 170 to 180 days on Seaboard's system carries genetics selected for lean muscle deposition rate, feed conversion efficiency, structural soundness of legs and feet, and reproductive performance in the sow lines that produce it. These traits don't accumulate in a single generation. They develop over years of selection pressure applied at the pure line level and transmitted through the commercial cross. Seaboard uses a 3-cross terminal cross program, the same structural logic that other large integrators use, where Yorkshire Landrace F1 sows crossed with Duroc sires produce the commercial pig. The F1 sow carries the maternal traits that make the breeding operation productive. Large litters, averaging 11 to 13 live pigs per farrowing, good milk production, and longevity through multiple reproductive cycles. The Duroc sire contributes lean growth rate and feed efficiency to the terminal cross that a Yorkshire or Landrace sire alone wouldn't provide. The company-owned sow farms where these crosses are made operate under strict biosecurity. Entry and exit protocols for people, vehicles, and animals reduce pathogen introduction risk in a population whose uninterrupted reproduction is essential to the pipeline's continuous flow. A disease event at a sow farm that reduces litter numbers or piglet survival rates propagates downstream. Fewer weaned pigs means fewer pigs reaching market weight 170 days later, which means a supply shortage at the Guymon plant's kill floor on a date that is calculable from the breeding calendar. The RFID tracking that Seaboard runs from birth to processing begins here at the sow farm when the weaned pig receives its identification tag. Litter number, birth date, sow identity, and farm of origin enter the system at this point. The pig's subsequent movements to a nursery barn, then to a contract finishing farm, then to transport for the Guymon plant, link to that founding record. 5 feed mills distributed across the production geography supply the contract farm network, with the rations that move pigs from 12 pounds at weaning to 270-plus pounds at market. The strategic placement of 5 mills rather than 1 reflects both the logistics of high-volume feed delivery and the redundancy that a supply chain of this scale requires. A single mill serving 400 contract farms would face delivery routes so long that freshness, cost, and timing would all suffer. Multiple mills, each serving a defined geographic cluster of farms, keep delivery distances manageable and build in supply redundancy. If one mill experiences a production outage, the adjacent mills can partially compensate rather than the entire network facing a feed interruption. Each mill sources corn and soybean meal from the regional grain market, purchasing through forward contracts and spot market acquisitions that the central procurement team manages. the Oklahoma and Kansas panhandles and the Texas panhandle all sit within the western extension of the Corn Belt's sorghum and corn production zone. Proximity to production reduces transportation cost and transit time for the primary feed ingredients. The ration specifications that Seaboard's nutritional team develops flow to all 5 mills as standardized formulas. This is not to say all pigs on all farms receive the same feed. The ration changes as pigs move through production phases, and the nutritional team adjusts formulas when ingredient prices shift the least cost optimal blend. But the nutritional standards that define each phase ration apply uniformly across the network. A pig on a contract farm in Beaver County, Oklahoma, receives the same ration specification as a pig on a farm in Liberal, Kansas. The standardization allows performance comparison across farms that is meaningful rather than confounded by feed differences. Feed delivery trucks run routes calculated to keep contract farm bins full without inventory building up beyond the capacity bins can hold. A finishing barn of 2,400 head consumes approximately 3,200 pounds of feed per day at mid-feeding period intake levels. A bulk bin holding 15,000 pounds provides roughly 4 to 5 days of supply. Delivery scheduling that replenishes bins every 3 to 4 days prevents runouts while limiting the time that feed sits in outdoor bins in summer heat. Conditions that degrade fat-containing ingredients through oxidative rancidity. The contract finishing farm model at Seaboard operates on the same structural logic that defines contract swine production across the industry. The integrator owns the animals and the feed. The grower owns the facilities and provides the labor, and the payment per pig reflects the grower's service contribution rather than the market value of the finished pig. A Seaboard contract finishing grower typically operates 2 to 4 barns, each designed to house between 1,100 and 1,300 head. The barn specifications that Seaboard requires for new construction reflect lessons from decades of operational experience with what ventilation systems, watering equipment, feeding systems, and floor designs produce the best pig performance and the lowest health costs. A grower who builds to those specifications gets a facility that functions as Seaboard's service technicians expect it to function. The service technician relationship is the primary operational connection between the integrator and the individual grower. Each technician serves a territory of 25 to 35 farms, visiting weekly and monitoring performance data between visits through the RFID-linked system that tracks feed deliveries and logs mortality and treatment records, and coordinating veterinary response when health challenges require it. Performance comparisons across farms in the same service territory, comparing feed conversion, mortality rates, and daily gain, provide both the grower and the company with benchmarking data. A grower consistently performing in the top quartile of their peer group receives higher payment rates under Seaboard's production incentive program. A grower consistently performing in the bottom quartile faces conversations with the service team about management practices and potentially about contract renewal. The RFID system that tracks individual pigs through the Seaboard network connects the contract farm data to the receiving records at the Guymon plant. When a transport load from a specific farm arrives at Guymon, the plant records the delivery weight, compares it to the placement weight recorded when those pigs arrived at the contract farm and calculates the average daily gain the farm achieved. That calculation, aggregated across multiple loads from the same farm, becomes part of the performance record that determines the farm's standing in the incentive program. Waste management at 400 plus contract finishing farms spread across the Oklahoma and Kansas panhandles operates under state environmental regulations that are specific to the agricultural context of each location. Each finishing barn generates liquid manure waste through the slatted floor and pit collection system beneath the barn. The lagoon systems that store and process this waste on Seaboard contract farms in Oklahoma operate under permits issued by the Oklahoma Department of Environmental Quality under the state's Concentrated Animal Feeding Operation Regulations. The permit specifies the lagoon design, the setback distances from water bodies and property lines, the monitoring requirements, and the nutrient management plan governing land application. A Texas county and the adjacent Panhandle counties sit on the Ogallala Aquifer, which underlies the region's agricultural economy. The water table depth in much of the area provides some buffer between surface activities and groundwater, but lagoon siting and design must account for the long-term vulnerability of a water resource that recharges slowly and has been declining under the combined draw of irrigated agriculture and municipal use for decades. Nitrogen management is a regulatory focus that drives land application planning on contract farms across the network. Swine lagoon effluent applied to cropland at agronomically appropriate rates supplies nitrogen and phosphorus that reduce or eliminate the need for purchased synthetic fertilizer on those fields. Applied at rates exceeding what the crop can utilize, the excess nitrogen either volatilizes to the atmosphere as ammonia, contributing to local air quality impacts, or leaches toward groundwater. The nutrient management plans that each contract farm must maintain under their DEQ, LQ permit specify application rates, timing restrictions, and field setbacks that govern how and when lagoon effluent moves from storage to cropland. Seaboard's production management team coordinates compliance documentation across the 400-plus contract farms, providing technical support for nutrient management planning and connecting growers with the state agricultural extension resources that help manage the agronomic and regulatory dimensions of waste management. A grower who fails to maintain compliance with their CAFO permit faces permit revocation, which means they cannot operate the finishing barns, a consequence that affects Seaboard's supply capacity as much as the grower's income. The Guymon processing facility's daily operation converts 18,000 live hogs into boxed pork products through a harvest and fabrication sequence that runs 2 shifts across a facility that employs several thousand workers. The kill floor schedule that drives the inbound transport logistics runs backward from the plant's throughput requirement. 18,000 head per day across 2 8-hour production shifts requires the kill floor to operate at approximately 1,125 head per hour, roughly 19 animals per minute at each stage of the harvest line. That pace sets the tempo for everything upstream: the transport arrivals, the lairage holding times, the unloading sequence, and the kill floor preparation that begins before first shift starts. U.S. DAFSIS inspectors assigned to the Guymon facility maintain continuous presence through both shifts. Ante-mortem inspection of live animals in the receiving pens. Post-mortem inspection of carcasses and organs at designated inspection stations on the line. and verification of food safety systems at critical control points, all run in parallel with the production operation under the federal inspection presence that is a statutory requirement for pork processing facilities producing for commerce. Automated fabrication systems in Guymon's cut-up and deboning operations handle portions of the fabrication work that manual cutting lines previously required entirely human labor for. Automated bandsaws, portion control conveyors, and robotic deboning systems for high-volume cuts reduce the per-unit labor cost and improve the consistency of portion weight compliance for retail and food service customers who specify tight weight tolerances on the cuts they purchase. The product mix that emerges from the Guymon plant's fabrication floor reflects the demand signals from Seaboard's customer base. Fresh pork loins, hams, shoulders, and bellies, the primary retail and food service cuts, move in boxed form to distribution customers. The belly destined for bacon moves to a separate processing stream. The trim from multiple cuts becomes ground pork or moves to further processing for sausage products. The entire carcass converts to revenue, with each component directed toward the product stream that generates maximum value relative to market prices. 3 million hogs per year. Moving that number through a pipeline that runs continuously requires more than operational efficiency at each individual stage. It requires that each stage's output exactly matches the next stage's input requirements, with tolerances narrow enough that neither a shortage nor an excess accumulates anywhere in the chain. The sow farms must produce enough weaned pigs to fill the contract farm's barn capacity on the placement schedules those farms need. The contract farms must grow those pigs to market weight on the schedule the plant's kill floor requires. The 5 feed mills must supply those farms with feed that arrives on time and meets the nutritional specifications that produce the growth rate the schedule assumes. The transport fleet must move those market weight pigs to Guymon within the windows the receiving schedule specifies. And the Guymon plant must process 18,000 head daily with the workforce, the equipment function, and the USDA inspection coordination that operation requires. When any element of this chain runs short or long, when a disease event reduces sow farm output, when a mill equipment failure delays deliveries to a cluster of contract farms, when a transport shortage leaves market weight pigs on farms past their optimal harvest window, the effects propagate through the system in both directions. Pigs held past optimal weight gain, suboptimal fat cover, or overfat condition that reduces carcass value. Gaps in plant supply create underutilization of fixed cost processing capacity that the economics of large-scale processing require to run near full. The RFID tracking system that follows each pig from birth identification to plant receiving does not prevent these disruptions. It makes them visible faster and makes the data available to manage through them more quickly. A supply shortage developing at the sow farm level shows up in the piglet placement projections 6 months before it affects the plant kill floor. A weight performance problem developing at a contract farm group shows up in the weekly tracking data before those pigs reach transport weight. Early visibility allows early response, adjusting breeding schedules, adjusting feed delivery, adjusting transport routing, in ways that compressed the disruption's downstream effect. The pipeline that Seaboard built from genetics to Guymon represents one complete expression of vertical integration in industrial pork production. It runs because its components were designed to fit together, because the data systems connecting them provide visibility that allows coordination at this scale, and because the contract farm model distributes the labor and the facility investment across 400 families in the Oklahoma Panhandle, without distributing the commodity risk that would make the system unmanageable for individual participants. At 4:44 in the morning, the first truck arrives at the plant gate. The RFID reader logs the load. The dispatcher updates the schedule. The kill floor supervisor checks the staffing report. The system opens another day. If this look at the integrated infrastructure behind 3 million hogs annually, from genetic selection through contract farming, feed production, and processing, gave you a deeper understanding of how large-scale pork production actually works, hit the like button and help the algorithm bring this content to more viewers. Subscribe for more deep dives into the production systems that run behind everyday food. Drop a comment and tell us where you're watching from. We read all of them, and the variety of locations never stops being interesting.